In this tutorial, we dismantle and reforge the default Claude Code to overcome its inherent flaw, the absence of persistent context across sessions. A problem that costs precious minutes each time you restart your AI assistant, causing repeated mistakes and wasted effort. The solution lies in a meticulously crafted memory system comprising primer, MD, a session state file updated at the end of every session, memory, MD, an indexed long-term memory store with typed entries for user, feedback, project, and reference, and the pre-tool use hook that automatically loads context upon startup. A problem that costs precious minutes each time you restart your AI assistant, causing repeated mistakes and wasted effort. This split between Alfred Code and Walter Desktop allows each AI to maintain a defined role while ensuring all memories are securely stored in ~production/. The memory system, born from our forge, survives even the most extensive wipe, remaining intact within the ~Claude/ folder. By externalizing session state into files and automating context carryover, we transform an AI assistant from a mere tool into a long-term partner that learns and adapts over time. This is the pattern that elevates our digital forge to new heights of productivity. Join us as we delve deeper into the EP4 persistent AI memory across sessions, the primer, MD plus memory, MD system. Chapter: The problem in the crucible of productivity, each second counts. Yet the default Claude Code, a powerful AI tool, fails to retain session memory, forcing you into the unproductive cycle of re-explaining pipeline state, open blockers, and current tasks. This inefficiency costs more than just time. It wastes 10 minutes or more per session, a significant drain of 50 hours a year for an average user. The common solution, a fresh start on every session, is broken. It leads to repeated mistakes and frustrating rework. You've experienced this firsthand, and the repetition weighs heavily on your forged workflow. The problem lies in the ephemeral nature of Claude Code's memory. Every session starts cold, forcing you to bear the burden of context that should be shouldered by the tool. The cost is not just time, but also accuracy. The broken solution forces you to recall details from previous sessions, increasing the chances of error and miscommunication. In a world where precision matters, this failure mode is unacceptable. It's time to forge a new path towards a more productive future. Chapter: The materials in our quest to fortify Claude Code with persistent AI memory across sessions. We have selected a composite of components, each serving a unique purpose. These materials are meticulously chosen for their robustness, versatility, and compatibility. 1. Primer MD session state file, a plaintext file that captures the current session state, rewritten at the end of every session to ensure accuracy and consistency. It is available free of charge, and its simplicity makes it easily accessible and editable by both human users and the AI itself. 2. Memory MD long-term memory store, an indexed plaintext file that stores typed entries for user preferences, feedback, projects, and references. This structured format allows for efficient retrieval and organization of information. The memory MD file is also updated at the end of each session, ensuring that long-term memory remains current and relevant. 3. Alfred Code/Walter Desktop, a split between Claude Code running on the command line Alfred and a desktop application, Walter. This division provides each AI with a defined role, enhancing their effectiveness in specific contexts. Both versions are open source and free to use. 4. Pre-tool use hook, an additional tool that reads the primer MD file automatically on startup, ensuring that the AI has immediate access to the latest session state without requiring manual intervention. This automation reduces the time wasted on re-explaining pipeline states and other contextual details. The decision to employ file-based memory over MCP, model-centric persistence, memory tools was made for reasons of reliability and ease of implementation. While MCP tools offer more advanced features, they can be complex and prone to errors, making them less suitable for our purpose. On the other hand, file-based memory provides a simple and reliable solution that has proven effective in this application. Finally, this entire memory architecture resides within the ~production/ directory, ensuring its survival even during full wipes of the ~Claude/ directory. This separation of critical data from ephemeral files ensures the longevity and continuity of your AI assistant. By externalizing session state into files and automating context loading, we have transformed an AI tool with no memory into a truly useful long-term assistant. This pattern is the key to unlocking the full potential of AI tools in our daily workflows. Chapter: The Build in the Crucible of the Forge. We shape the Claude Code to bear a new burden-persistent AI memory across sessions. Our anvil today is a system composed of Primer, MD memory, MD Alfred Code, and Walter desktop, each element tempered to serve its purpose. First, let's address the broken. Claude Code starts fresh in every session, wasting precious minutes re-explaining pipeline state, open blockers, and current tasks. The furnace of repetition forges no progress. Our solution is a twofold memory architecture. First, we craft Primer, MD, a file that captures the live session state and gets written at the end of every session. This file will serve as our session's compass, ensuring we never lose our way. Navigate to your user directory, bash cd:/production, initialize a new file named Primer, MD. In this file, you can write down any important notes, open blockers, and current tasks for the session. Here's an example. Markdown #session1 ## open blockers bug in function x issue with library y ## current tasks 1, debug function x2. Upgrade library y. Next, we forge memory, MD, an indexed long-term memory store with typed entries, user, feedback, project, reference. This will serve as our AI's hard drive, storing valuable data across sessions. Bash touch memory, MD. Inside the file, you can structure your data using key-value pairs or any other format that suits your needs. However, crafting these files is only half the battle. To ensure our AI carries context forward automatically, we need a pre-tool use hook to load context from Primer, MD on startup. Navigate to your Claude Code directory, bash cd:/. Claude, open the config, YAML file, bash nano config, YAML, add the following line under the hooks section, YAML pre-tool use, load Primer MD in a new file named load Primer MD, pi. We'll define our hook to read Primer MD and load its contents into Claude Code's memory. Python import YAML from pathlib import path def load Primer MD, Primer equals path ~production/Primer, MD, expand user, read text, data equals YAML safe load, Primer, #load data into Claude Code's memory as needed. However, crafting these files is only half the battle. To ensure our AI carries context forward automatically, we need a pre-tool use hook to load context from Primer, MD on startup. Now let's temper our AI with a defined role for each environment: Alfred Code and Walter desktop. This split ensures each AI variant serves its purpose without encroaching on the other. YAML #config, YAML environments, code, #configuration for Alfred Code desktop, #configuration for Walter desktop. By externalizing session state into files, we free ourselves from being the memory. Now let's temper our AI with a defined role for each environment: Alfred Code and Walter desktop. This file-based system outshines MCP memory tools in reliability and robustness. With this pattern, an AI assistant becomes a valuable long-term companion rather than a temporary ally. Throughout this process, you may encounter errors. Two common ones include: 1. Incorrect path to Primer, MD. This may occur if the path to Primer, MD is not correctly specified in the pre-tool use hook, or if the file isn't located in the expected directory ~production/. To fix, ensure the correct path is used and that Primer, MD resides in the designated folder. 2. Syntax errors in Python scripts. These can occur due to incorrect indentation, missing parentheses, or unrecognized functions in your Python scripts. A simple solution is to use a linter or code formatter, like AutoPep8, to automatically correct these issues. With these tools forged and tempered, we now possess a persistent AI memory system that carries context forward across sessions, the essential foundation for an AI assistant that truly assists over the long haul. Chapter: Deep Dive in the Crucible of Productivity. The Claude Code was forged to serve as an artificial intelligence companion. Yet it faltered in retaining memory across sessions, forcing users to waste precious minutes re-explaining pipeline state, open blockers, and current tasks at each new session's commencement. This tutorial delves into the remedy forged from that weakness: the Primer, MD file as a session state repository, the memory, MD indexed long-term memory store, the Alfred/Walter split, and the pre-tool use hook that automates context loading. The Primer, MD is rewritten at the end of each session, capturing the ephemeral state of the ongoing work. This file serves as a blueprint for the next session, ensuring continuity without the need for human intervention. The memory, MD, on the other hand, functions as a long-term memory store with typed entries that include user preferences, feedback, project details, and references. The Alfred/Walter split is a strategic division of roles between the AI assistants. Alfred takes charge as the code-centric companion within the Claude Code ecosystem, while Walter assumes responsibility for the desktop environment in Claude Desktop. This segregation allows for specialized focus and efficient problem-solving. To integrate this memory architecture seamlessly into the Claude Code, a pre-tool use hook was forged to automatically load context from the primer MD file upon startup. This streamlined workflow eliminates the need for manual intervention and ensures that the AI assistant carries forward the context automatically. File-based memory solutions such as the primer, MD, and memory, MD proved more reliable than memory context processors, MCP tools in this application. The former survived the full wipe intact, residing securely within the /production/ directory rather than the user's Claude Code configuration folder /Claude/. Two common pitfalls arise when implementing this memory architecture. 1. Neglecting to store the primer, MD in memory, MD files in the appropriate location, /production/, and 2. Overlooking the pre-tool use hook integration, which can lead to context not being loaded automatically upon startup. The former survived the full wipe intact, residing securely within the /production/ directory rather than the user's Claude Code configuration folder /Claude/. By externalizing session state into files, users are relieved of the burden of maintaining memory for their AI assistant. This pattern is the foundation that transforms an AI tool into a genuinely useful long-term partner in productivity and innovation. Chapter Stress Test. In the crucible of real use, the Claude Code memory architecture was subjected to rigorous testing. The initial setup revealed a critical flaw: no persistent context within the default code. Each session commenced cold, necessitating 10 minutes or more for re-explaining pipeline state, open blockers, and current tasks. This repetition led to repeated mistakes and inefficiency. To temper this weakness, we forged Primer, MD, a session state file that gets updated at the end of each session, acting as a living chronicle of the AI's work. Alongside it, Memory, MD emerged as an indexed long-term memory store with typed entries for user, feedback, project, and reference data. The pre-tool use hook was integrated to automatically read Primer, MD during startup, ensuring seamless continuation of tasks from one session to the next. To further refine the system, we split Claude Code into two distinct entities: Alfred Code and Walter Desktop, each with a defined role. This separation allows for efficient task distribution and improved performance. All memory components were carefully placed within the /production/ directory, ensuring they survived the full wipe of the /Claude/ folder intact. The new system proved robust against the heat of heavy use, demonstrating its ability to carry context forward automatically, relieving users from being the memory repository. The stress test revealed that file-based memory systems are more reliable compared to MCP, model, code, prompt, memory tools. This pattern is the key to transforming an AI assistant into a truly long-term valuable tool. The forging process continues as we refine and strengthen this memory architecture to meet the demands of real-world applications. Chapter The Output. In the crucible of the forge, we've tempered a solution to address the issue of Claude Code's lack of persistent context. The result is a memory system that not only maintains session state, but also stores long-term memories in an organized manner. The heart of this system lies in two files: Primer, MD, and Memory, MD. Primer, MD, written at the end of each session, serves as a live record of the current session state. Meanwhile, Memory, MD, is an index store for long-term memories, categorized by user, feedback, project, and reference entries. To ensure division of labor and efficiency, we've split Claude Code into two distinct entities: Alfred Code and Walter Desktop, each with a defined role. This separation allows the AI to perform optimally in their respective domains. To facilitate seamless transition between sessions, we've implemented the pre-tool use hook, which automatically loads context from Primer, MD, upon startup. By doing so, we eliminate the waste of 10+ minutes per session spent on re-explaining pipeline state, open blockers, and current tasks, reducing repetition and potential errors. The benefit of this system is clear. It relieves users from having to act as the memory for their AI assistant. By externalizing session state into files, the AI can carry context forward automatically, a pattern that makes an AI assistant truly useful long-term. This system has proven its resilience, surviving a full wipe without loss of data because it resides in /production/, not /Claude/. This forged solution produces a tangible result: time saved, mistakes reduced, and a more efficient workflow. The numbers speak for themselves. With this memory system in place, the AI is no longer starting cold with each new session. Apprentice, your task today was to address the cold start issue in Claude Code by implementing a persistent memory system. You forged a robust solution using Primer, MD for session state memory, MD for long-term storage, and split roles for Alfred and Walter. The pre-tool use hook ensures context is loaded automatically upon startup. This new design improves efficiency, reduces errors, and makes the AI assistant truly useful in the long run. As you leave this forge, remember that externalized memory will be your key to building an enduring relationship with your AI companion. Forged well, apprentice. Now, let the AI carry the burden of memory so you may focus on the craft at hand.